So good morning, everyone. This next talk will be held in English. The speaker will be Matej Líner from Labyrinth Labs, and he will tell us how to save some money during our sleep.
Thank you. Can you hear me? All right. So again, good morning, everyone. Welcome to KCD 2024. My name is Matej, and during this presentation, I will talk about the topic of saving money while sleeping, where we will discuss the concept of scheduling scaling. First of all, let me introduce myself a little bit more. I'm from Slovakia. I work for a local company called Labyrinth Labs for 2 years, basically. For last 10 years, I work as an IT specialist, and during that time, I was basically helping customers to migrate their applications and run those in cloud. I have a strong passion, I would say, in standardization and process automation, and one of my key allies is Terraform. Something about Labyrinth Labs. Labyrinth Labs is a one-stop shop for DevOps, Kubernetes, and cloud. We are a bunch of IT experts, especially 20 of us, and we have some missions. One of those is to transfer businesses to become cloud native and future ready. And the other one is to help our customers to seamlessly move to cloud with their workloads, into cloud. Yeah. So let's go to the problem of these presentation, and that's the money waste. To better grasp the problem, let's start with some statistics. So I took those from various surveys. One of them is saying that cloud spend is growing by average of 35% year over year. Another one is that many organizations waste almost 32% of their cloud budget. It means that basically most or 32% of their workload is not correctly used or it's unused at all. 72% of organizations are setting resources too high, so it's also one of the common problems. And right-sizing infrastructure can cut costs by 36%. Another set of statistics is that 64% of organizations are not fully utilizing autoscaling. This means that basically they are running the static number of their resources without any automation to scale in or scale out. Only 13% of provisioned CPU is actively used, so this means that we are just wasting money by idle resources. Kubernetes platform is usually over-provisioned by 30%. Again, over-provisioning, so it means that a lot of resources not being used, and those are basically idle. And the last one, and basically the one we are going to talk about during this presentation, is scheduled shutdowns can save around 60% of non-production costs. Based on those statistics, we can basically define some common problems, and I have mentioned those many times. One of them is over-provisioning. What over-provisioning means that we are excessively allocating resources to some workloads, and those resources are not being used. Different way how to look on it is also underutilization. So it's when you take the problem from a different way or from the other way, it also means that the resources are being used in low rates. And to actually commonly call it, it's inefficient resource allocation. Another problems that we can actually understand from those statistics are lack of automatic scaling. I mentioned this, there was one statistic specific for that. And that's it. That's the problem of inability to scale in or scale out based on the current load. So it's a quite common problem for many organizations. And the last one are the idle resources. So it's also the way how to actually how to describe all of those before. All right, so the money waste equals idle cost, or the other way around. Idle cost equals money waste. So idle cost means that we are paying for something that is not being actively used. We had a problem, or we have a problem, so it's money wastage, and there is also a way how to fix that, and that's by using the concept of scheduled scaling. There is one of the common rules to actually get rid of idle cost is to don't run it when you don't need it. So it's one of the golden rules of scheduled scaling. What is scheduled scaling? Basically, in a common tongue, let's say, it's an automatic process that is trying to adjust resource allocation at the predefined times, you know. And these help us to optimize performance and also lower costs. We have some scheduled scaling types, let's say. One of them is time scale in and out based on some minimal or desired state. So if I want to do a scheduled scaling based on what I want to have. For example, I want to have at that particular time only one instance or one replica of a Kubernetes pod, then I will do it in some way, which we'll discuss in another slide. So that's one of the types. The other type is to completely shut down or start up the environment or some deployment on some predefined time. These two types are different for every environment. So let's go to environments. We are, in this case, for scheduled scaling, we are talking about two kinds of environments. One is non-production environments, and the other one is production environment. For non-production environment, we are talking mainly about dev, test, staging, or any other sandbox that we have. These kind of environments or non-production environments, they make about 60 to 70% of environments that usually organizations have. 44% of cloud spend is on non-production environments. So you can see the scale of it, that when you have so many environments, then you can, if you have a lot of money waste on those environments, then you can save a lot of money. And 76% of time these environments are idle, so they are not actively being used, and yeah, that also means money wastage. Let's have a typical example. So we have a non-production environment which is being called, for example, dev, which is running 24/7. It's quite common for companies which are developing some solutions, that they are just simply letting their developers to run also outside of working hours and during weekends as well. So it's basically running 24/7. And if we take that the standard business hours or working hours are from 9 to 5, then we can say that the environment is being actively used only 40 hours a week, right? So if we can count it, it means that there is around 67% of running time that is being actually wasted. How to optimize this? We can do multiple things that are related to scheduled scaling. We can set up automatic scheduled shutdown of the environment or of a certain workload. It means that we need to set the desired state after working hours to 0, so basically shut it down. And right before the working hours or business hours, we want to scale it out, so start the environment to at least some desired minimum. And after that, we just let the auto-scaling do its job. So when I get back to the previous example, again, we have developers which are working from 9 to 5, and outside of these hours, the environment is basically turned off, and there is almost no cost related to that. Production. Production is one of the typical cases for over-provisioning, and that's because organizations or companies are trying to over-provision their production environments just because they wanted to be able to handle a sudden peak in a load. So during the business hours, right? You might think that the automatic scaling or auto-scaling is sufficient for that, but when you imagine that there is a sudden load, for example, I don't know, there is an event or something like that, and there is a lot of new users trying to connect to your service, then the auto-scaling, which is basically a gradual adjustment of assigned resources, cannot handle such load in a short time. So that's why you need to buffer an extra resources to actually remain running. Examples for production. For production, there are two kinds of examples. First one is related to planned events. So, for example, there is one of commonly used events in e-commerce is Black Friday. So during the Black Friday, you know that Black Friday starts at, or the sale starts at 5 p.m. and you can basically pre-scale the environment to handle the sudden load. So you will just increase the resources that are allocated to that service. And after the event, which ends during the nighttime, let's say, you can just scale it down to save costs. And also, the other example is, for example, very similar. It means that before the business hours, you have, for example, you have some application, and you know that during the business hours, the load is 2 times higher, let's say, and you just pre-scale the environment right before the business hours to match the load, and after the business hours, you will just lower the resources to handle just the minimal load, which is usually there. All right, schedule scaling in Kubernetes. That's the topic. You can do it in 2 ways, basically. I will mention this one, the first way, and I will mention it, but I will say that it's not that safe to do. You can do a scheduled scaling of the whole cluster, so it means that you will basically create or remove the whole cluster with all the nodes, all the workloads, and data control plane and everything that is related. It brings you the biggest cost saving, of course. For example, if you are running on AWS, you don't pay for EC2 instances, you don't pay for the control plane, so it's the biggest cost saving. However, this brings you a lot of problems. One of those is that it's slow on creation, and it has a negative impact on the dependent services. So if you have some some pipeline. For example, very good example is the Terraform code. So if you have a platform which depends on some AKS cluster, for example, and you are depending on that based on some outputs, then you are not able to continue with another deployment because, for example, the ID of AKS cluster is changed. So yeah, that's one of the main negatives for this kind of schedule scaling. The other one is workload specific, and this is far more faster and far more safer option than the previous one. And what you can do, you can basically scale down or scale up deployments, stateful sets. You can, for example, shut down the cron jobs and so on. You can do it also namespace based, so you can do it in a bulk way, let's say. So you will define that you want to shut down this namespace and you need to postpone all the cron jobs, for example. Or you can, for example, do it in a node based, so you will scale down the nodes that are part of your cluster. What kind of Kubernetes tooling are being used or is being used for scheduled scaling? So let's talk about that a little bit more. KubeGreen. KubeGreen is an open source and part of a CNCF landscape tool. It's a Kubernetes operator that reduces CO2 emissions by suspending pods and cron jobs during off hours. And also it resumes those pods when we need them. And under the hood, it uses a lot of cron jobs. So that's it basically. It also has some limitations. So it supports only scheduled startups and shutdowns. So it's not able to do a schedule scale in or scale out if you want to lower your replicas to smaller number, for example, based on time. The other limitation of KubeGreen is that it targets only deployments and cron jobs. So if you have some CRDs that you have developed, you are not able to actually handle those with KubeGreen. And the last one is inability to set dependencies between the scaled down objects. So for example, you have two namespaces and you want to shut down all those two namespaces, but you are not able to specify which has a precedence over the other one. So this might bring some problems when you have dependencies, real dependencies with your services. All right. Let's go to examples. So example one, you can see a Kubernetes manifest for KubeGreen, where the definition says that you want to suspend your cron jobs, and that should be suspended from 8 p.m. to 8 a.m. And it should also, this means that it will suspend all the namespaces, all the pods in your cluster, but you want to exclude some deployments of services. So you will say that you want to exclude from that turn shutdown, you want to suspend a deployment called API Gateway, for example. All right, so the other tool that can be used for scheduled scaling, shutdown or scaling out or out, are the Kubernetes built-in cron jobs. It's meant to be for scheduling of regular tasks using cron syntax. Can be used to schedule resources with help of custom scripting. And those these cron jobs are commonly part of the application definition, so it means Helm chart, for example. There's an example for cron jobs. This is also a Kubernetes manifest that is saying that at 7 a.m. daily, I want to shut down or scale the replicas to 3 on deployment up yet 1. So this is an example when you are actually using the custom script or custom program that you want to, which we want to use to actually do the scale up or scale down or shut down, whatever. Another tool, Sleeper. It's a Kubernetes wrapper, I will call it. It's a Labyrinth Labs in-house built-in tool, and it's a wrapper over KubeGreen with some additional functionality, which is mentioned below, and we are actually doing a startup or shutdown of nodes, because KubeGreen is not able to do shutdown of nodes. So we are aiming to do EKS managed nodes shutdown or startup, and also Carpenter nodes startup or shutdown. Here is an example. So in this particular example, we are trying to scale down an EKS managed nodes, which are part of the. I'm not sure if you are familiar with EKS, but it's Kubernetes service in AWS. And here you can say that you want to shut down the environment for a node pool profile system. So system nodes will be shut down at a certain time. The other example is related to Carpenter nodes. So it's almost the same as the managed nodes in EKS, but this one is aiming for Carpenter nodes. Also the same time and same behavior, basically. Here we are aiming to scale down 2 Carpenter pools. One is called system and the other one is called app default. And there is also a third example, and this is about scaling a namespace. So it means that I want to scale down a namespace's default app 1 and app 2. I want to also exclude a deployment or specific deployment which is called test. And also I want to suspend cron jobs which belong to the namespaces that are mentioned here. So as you can see, it's quite, you can quite easily do a scheduled scaling with these tools that I have mentioned. We also plan to do plan to add some additional functionalities to Sleeper, and it's about pausing managed databases like RDS, or schedule a scale-in or scale-out of managed services like Redis or Elastic Cache, and also do some pre-provisioning of throughput for Lambda functions in AWS. All right. And the last tool I will mention here is KEDA. KEDA is even though it's an event-driven autoscaler, it can also be used for schedule scaling. So KEDA actually extends Kubernetes autoscaling capabilities. As I mentioned, it's an event-driven scaling for deployments and stateful sets. It allows us to scale in or scale out based on some external sources or triggers, let's say, let's call it like that. And those can be HTTP requests, message queues, Kafka topics, cron jobs, for example. And with these cron jobs, it can also support the scheduled scaling as such. Here is an example of that. So also Kubernetes manifest for Kafka scaled object. And it says that you want to do a scale in or scale out based on a queue, which is mentioned down below. So if you have a message in a queue, you will read it, and based on that you can define if you want to scale out or scale in. The other example is about KEDA using time scaling. So the trigger, which is actually triggering the KEDA to scale, is a cron job. So again, at 6 a.m. or it starts and it ends in 8 p.m. And I want to say that there is a minimum replica count to 0. So yeah, between the time it will be there will be 10 replicas running basically. So from 8 p.m. to 6 a.m. it will be only there will be no replicas running, and the environment will be basically shut down. All right, that's about it. Any questions? I can read it.
Yeah, we have many of them.
Isn't such time schedule scaling up and down a large step back since there are pod instances in the town? No, because you still have to pay for those pod instances, so that's basically the answer. Are work hours really relevant? Work time could be very flexible, someone working at night, and there could be a couple of maintenance night jobs, and 3 dots. All right, so yes, it's a good question. There is a way how to actually wake up the environment if you shut it down. So basically, there are some possibilities how to tackle this. But from my experience, also from my previous work, where there was like plenty of developers running outside of working hours, it's not good practice to do outside of working hours. That's the main answer that I wanted to give you from. Yeah. In your experience, are your customers already that far in Kubernetes journey that you can discuss autoscaling, or can they currently consider only cron schedule? If you stop by our booth, we can talk about our platform, which is called Lara, and basically the platform is cloud ready, and we are having autoscaling in place. So every customer which is running on our platform is trying to use that autoscaling. So yeah, most of our customers do already use autoscaling. Totally understand the node scale down savings, but what are you really saving when scaling down deployments for certain periods of times? Can you give example? Yes, I can. For example, I will mention Carpenter again. You have a certain load or certain workload on Carpenter. Let's say you have a deployment with 5 replicas, and outside of working hours, you want to you want to scale down those replicas to 0, and basically Carpenter will see it, and it will scale down the instance, or basically shut down the instance. So by scaling down the number of replicas, you can also scale down the number of nodes you are having as part of your cluster. So that's the answer. I know a cloud-native PG function, suspend resume, which kills pod but keeps storage. Are these similar functions in other projects except Knative or KEDA? I'm not sure about this one. We can talk about it after the presentation. And the last one, what to do in case of sleeper and autoscaler conflicts on node management. CAS should be disabled or special node groups used. Yeah, it might be. It might happen that there will be a conflict. However, I think that here, lowering the number of replicas by changing the deployment will make precedence over autoscaler, I guess. Okay.
Okay, so
Thank you.
That's it. Thank you very much for the talk. And now it's time for 15-minute break. So grab a coffee.